Okay, today we're not going to learn anything new. We're going to work on applying the formulas in like word problems that we've already learned. Um, Basically, we're going to do segment formulas today. We're going to use the segment formulas. So, um, in a lot of these, the segment formulas are used a ton in astronomy and calculation for space travel and distance and things like that. So one thing you need to know to do a lot of these problems is that the Earth's radius is 4,000 miles. So you can see right here from the center of the Earth to the edge of the crust here is 4,000 miles approximately. So you need to know that. You need to jot it down because we're going to be using that a bunch. All right, so let's do this first problem. All right, so there's a picture of Skylab. It's 3,600 miles from Cape Canaveral when it first appears on the horizon. So we do that, that occurs a lot when we're doing calculations because if it first appears on the horizon, that becomes the line of sight from the shape to the Earth is then a tangent. Okay, so you hear that a lot when we're doing these kinds of problems. Um, the the way that they've been able to calculate some of this stuff is they know that when the object first appears on the horizon, that is creating a tangent, that one point um, for the Earth. All right, so they said that Skylab is 3,600 miles from Cape Canaveral when it first appears on the horizon. So that means the distance from Cape Canaveral right here to Skylab is 3,600 miles. Okay? Appears during its orbit. How far above the Earth is the satellite? So we're looking for this piece right here, correct? And uh, we know that a radius, because here's the center of the Earth, out to the edge, a radius of the Earth is 4,000 miles, and we know that a tangent line drawn to a radius makes a right angle. So we can use Pythagorean theorem, easy peasy, right? So the radius is one of the legs, that's 4,000. The distance to the satellite is the other leg, 3,600. And the hypotenuse is, you can just solve for the hypotenuse and then subtract, or you can do x plus the distance that we're looking for, or 4,000 plus the distance we're looking for. I think it's easier to do it this way. But if you want to, you can say 4,000 squared plus 3,600 squared is equal to, and then we know this distance is 4,000 plus x squared. And then you're solving for that distance we're looking for here. So either way you want to do it. To solve it like this, subtract 4,000 or solve for that. All right, so, okay, we need a calculator. That's the square root of 4,000 squared plus 3,600 squared. And that gives me 5,381.4 square feet, or square miles, 4,381.4 square miles, or miles, sorry, not square miles. And then we know that the radius, this distance from the center of the Earth to the crust, is 4,000. So I'm going to take away that 4,000. So it must be 1,381.4 miles above the Earth. right? So that's an example of how we can use the the segment formulas we learned, secant, 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 tangent, chord, chord, to solve for real world problems. All right. The next one is for a Native American design. They've got 8 points. It looks like a compass. You'll notice there's north, south, east, west, and then exactly in between each one. BE, so this distance here is 3. AE, so from here to here is 5.2. And EC from here to here is 4. So we've got a distance here, and we've got a distance here and here, and I'm guessing we're looking for DE. Yep. So we're looking for this distance. So that's chord, chord. So 5.2 times 4 should be equal to 3 times DE, which we'll call X. So that's 20.8 is equal to 3X. Divide by 3. And that gives me 6.6 equals X. So DE is 6.6. The diameter of the circle would be 6.6 plus 3, right? Or 9.6. Because DE, see how DB goes to the center O of the circle? So that's why I know that's going to be the diameter. So that, sorry, not X, diameter. Okay? And the last one is OE to the nearest hundredth. So OE is from the center of the circle to E. So we know that the diameter is 9.6. So half of that would be the radius. So divide by 2. And that gives me 4.5, 4.8. So the radius is 4.8. So if you look at the circle here, 4.8 is from here, the center, out to there. And so we've used up 3. So from E to O, the rest of the diameter must be 1.8. Okay, and those are the answers to those. All right, now take a minute and just, this is like one of those little circle puzzles, except instead of trying to find angles, now we're trying to find lengths of segments. So take a minute, do this on a separate sheet of paper to turn in for tomorrow. Okay?